Hello students, so this is a question from electrostatic and there is a parallel plate capacitor at a distance x is equal to 0 and at x is equal to d, and both are at zero potential, and there is a profile of charge density about this x distance. It is given rho is equal to rho naught e to the power minus x, and we have to get potential at this point P. So think about an equation that relates potential with charge density. Yes, you are right. So it is Poisson equation. Okay? Del square V is equal to minus rho by epsilon naught. You can quickly derive also Gauss theorem. Del dot E is rho by epsilon naught, and E is equal to minus grad of V. Put it here, you will get this equation, which is known as Poisson equation. Now this Poisson equation in one dimension will take form del 2V by del x2 is equal to minus rho by epsilon naught. Correct? Now we have to solve this differential equation. Just put the profile. What is this rho is equal to? It is rho naught e to the power minus x by epsilon naught. Okay? Now integrate it once, you will get del v by del x is equal to minus rho naught by epsilon naught e to the power minus x, and minus sign was there, so it will become plus, and this is a constant will be introduced, that is C1, constant of integration. Correct? And if you integrate it one more time, you will get minus rho naught by epsilon naught e to the power minus x plus C1 x plus C2. Right? So this is the profile. Now you can put the boundary condition that at x is equal to 0, v is equal to 0, and at x is equal to d, v is equal to 0, and get the value of C1 and C2. Now this first term of the equation is not going to change with whatever values you get C1 and C2. So you can just put it and get the values, but still I am telling you that this value will not change. So that means the first term will have coefficient rho naught by epsilon naught. Here it is rho naught by epsilon naught, here it is 2 rho naught by epsilon naught, here it is rho naught by 2 epsilon naught, and it is 3. So all these options, they are wrong, because this term is not going to change with boundary condition. So whatever terms are coming, they will come by putting the boundary condition, but first term will remain unchanged. And here if you take minus rho naught by epsilon naught common, you will get e to the power minus x minus C1x minus C2. So actually this is the answer. These values of C1 and C2 you will get by putting the boundary condition. The problem is here there is no negative sign. I think they have made a mistake, because they have not said that Vx is proportional to, otherwise that was a correct option, but I think they have made a mistake. And if I just ignore that they are asking the proportional potential is proportional to, then answer A could be correct, otherwise they must have given a negative sign. Now quickly, if you want to know what are the values of this, put the boundary condition at x is equal to 0, v is equal to 0, so rho naught by epsilon naught, here it will become 1 minus C2. Okay, so put x is equal to 0, so v is equal to 0, so you get the value of C2. What is C2? C2 is equal to 1. and at x is equal to d, this is also 0, so 0 minus rho naught by epsilon naught e to the power minus d minus c1d minus 1. Get the value of c1 from here. So c1 will be equal to e to the power minus d by d. Okay? c1 is e to the power minus d by d. Now you can check here, c1 is e to the power c1d, just a second, this is equal to 0, so c1 is equal to e to the power minus d minus 1 by d from this equation. Alright, so put this value and then this is correct answer except that negative sign which is missing. So this is a good question based on basic Poisson equation of electrostat. Thank you.